Well, hello there. Today we'll be learning about isosceles and equilateral triangles. And we have learned the definitions, but now we'll be learning a little bit more about them. So, our first theorem for today is called the base angle theorem. This, as you can see, is dealing with an isosceles triangle. So we know it's isosceles because we have two legs that are congruent. So in an isosceles triangle, the congruent ones are legs. That third side is called the base, and then the two angles that are adjacent or touch that base are your base angles. The angle that's not one of the base angles we call the vertex angle. So you got your isosceles triangle. The legs are the congruent ones. Base angles should be at the bottom or touch each one of those legs. So base angle theorem says if two sides of a triangle are congruent, so you could say if you have an isosceles triangle, then the angles opposite of those congruent sides are congruent. Or you could say the base angles are congruent. So long story short, this says in any isosceles triangle, your base angles are congruent. So again, notice your base angles are opposite of your legs. So these two angles are going to be congruent. We can also say the converse of that. So converse of the base angles theorem says if your base angles are congruent, then those sides that are opposite are congruent. So you can say that AB and AC, those segments are congruent. So it works both ways. So when you have an isosceles triangle, base angles are congruent and the legs are congruent. Okay? Or if the legs are congruent, then the angles are congruent and vice versa there. And then we have a couple corollaries that kind of go along with your base angle and converse of base angle theorem. First one says if a triangle is equilateral, then it's equiangular. Second one's the converse. If a triangle is equiangular, then it's equilateral. So anytime you have a triangle that is equilateral, where all the sides are the same, all the angles are going to be the same. And then same thing backwards. If all the angles are the same, then all the sides are the same. Now this only works with triangles, because if you think about something like a rectangle, just because all those angles are 90 degrees doesn't mean all your sides are going to be the same. So this concept is only going to work with triangles. So equiangular means it's equilateral, equilateral means it's equiangular. So solving for some variables here. I don't know how easy this is to see, but that's a 3x. And maybe I'm making it harder, I don't know. That's a 2x. So here we have an isosceles triangle. We know that our base angles, because they're across from our legs, are going to be congruent. So I would have 3x minus 11 equals 2x plus 11. So subtract 2x and add 11. X is 22. Well, then how do we get 2y? Well, if we take our 22 and plug it in, well, 22 times 2 is 44 plus 11. Each one of these guys is 55 degrees. So that should help us figure out what this last angle has to be. We know all three have to add up to 180. So 180 minus those two is going to get us 70. So if 2y equals 70, divided by 2y is 35. So again, things we learned earlier in the chapter, earlier in the year, we're still going to be using. Next example. Well, you should notice you have a right triangle. So these two angles. Now just looking at this diagram, you should know the measures of each of those. And you should know that because you know the angles in a triangle add up to 180. So obviously you subtract the 90. So you have 90 degrees left. Well, since these two sides are congruent, these two angles are congruent. And if you cut 90 in half, you get 45. So 3x equals 45. And x is 15. And then y plus 7 equals 45. So y is 38. Pretty simple stuff. And we're going to throw in one last example. Just find the perimeter of the triangle. Well, perimeter is all the sides added up. So I can add all these sides up, but I'll still have x's in it. But I do have base angles that are the same. So if I go opposite, these two sides should be the same as well. So that would be 5x minus 7 equals 10x minus 32. Negative 7 would equal 5x minus 32. We're going to add 32 to the other side, get 25. So x is 5, so I'm going to plug that back in. Well, 5 times 5, 25, minus 7 is 18. Should get the same answer here if I did my math right. 50 minus 32, 18, and then you add up your sides. So 36 plus 14, perimeter would be 50 inches. So again, main concepts of the day. If you have an isosceles triangle like that, that means your base angles are the same. Or, if you have an isosceles triangle where you know the angles are the same, that means the sides are the same. If it's equiangular, it's equilateral. If the triangle is equilateral, then it's equiangular. So those are the main concepts today. And lucky for you, no proofs on your assignment. So this will be due, we'll correct it on Monday when you get back from Thanksgiving. So everyone should be done with this. Hopefully you get it done before Thanksgiving so you can relax a little bit. And hopefully actually get it done, and hopefully you're actually watching the video. That concludes the lesson.